Okay, let's get this party started. So yeah, I'm David Corrado. I'm gonna go through Android best practices. My slides are very uninteresting, but feel free to ask me any questions throughout this. And essentially, my premise here is I just kind of went through some apps I've been building lately, or just looking through blogs and taking notes of, and then just taking notes of what I think is best practices and what are previous practices, because Android's constantly evolving. So I'm interested to hear your guys' thoughts on my thoughts, because I'm kind of being opinionated here, and also Android's being opinionated. So sharing Android's opinions and also my opinions. Let me scoot up a little bit so I can see my screen. Okay, so I will start here. So obviously, the recommended language in Android is Kotlin. It's been recommended since 2019, and basically, for the most part, nobody should be using Java anymore. I'm sure there's lots of applications. I've seen a lot of interviews, like GitHub examples where people started using Java, and just if you're trying to get a job, you should probably learn Kotlin, because most jobs have evolved to Kotlin for Android now. Well, everything's incremental, so most companies are not 100% Kotlin, but essentially what they do is they have the team generally agrees on a policy of how you migrate to Kotlin. So my last job at FanDuel, our rule was every single time you kind of sufficiently modified a file, you converted it to Kotlin. Or I was super aggressive, so if I even touched a file, I converted it to Kotlin. So it's kind of just
more curious about how long it took
to learn it. I don't think, the thing is, I don't think any language is particularly hard to learn. Essentially what you do to learn Kotlin, in my opinion, is you write Java looking code and have it work in Kotlin. And then what happens is in the assigned margins of Android Studio, it will tell you everything that you're doing wrong. So it'll suggest, hey, you're using if statements, you should be using when statements. That's the new way to do it in Kotlin, et cetera, et cetera. Or you're not handling nullability correctly. You can just do it like that. I think that's how most people probably learn Kotlin, is they just do Java-esque, and then it a lot of people don't pay attention to that side margin, which is bad, because I also have it later in this guide that you should pay attention to that side margin, because what it does is it teaches you how to do Kotlin properly as well. Well, I don't know if you're doing Kotlin. I guess you could do it in IntelliJ, but if you're doing Kotlin for Android, you probably should be using Android Studio. Yeah, and I think if you're doing, but if you're doing backend dev, I've done some backend dev just personal project wise, and IntelliJ and Android Studio are the same IDE. They're basically the same thing. They're built by the same company. So if you use, you're a Java dev, right? So you've used IntelliJ, sure. Yep. So they're basically the same thing. They work exactly the same. So yeah, that's feel free to continue interjecting if you have any comments. I have a lot of slides here. So the next thing is what language you should do your Gradle. So right now, it's really, really popular to do Groovy. That's the standard way to do Gradle. Previous things were Maven and Ants. Nobody uses those anymore. But basically, every project, when you default create a template project on Android, it'll create it in Groovy. But since April of 2020, they released the ability to do Kotlin in your Gradle file. And you don't want a second. So basically, it's not fully recommended yet, because I think the reason why is because they don't have any Gradle to Kotlin converters, and they want to probably make it easy for you. But almost every documentation that I've seen on the Android site shows an example in Gradle or Groovy, and an example in Kotlin. I can show you an example of what this looks like too. Okay, no, it's all good. So essentially, here's a guide how I'm going to show these slides later after this. Everybody can kind of do deeper dives and stuff. But if anybody's interested in what the Gradle file, essentially what it does on Android, you have two different ones. You have the root level and then you have the app level. So in here, you just convert this file to, and this kind of tells your dependencies in your apps. So the essentially, there's just a guide on how to convert it to Kotlin. I would imagine eventually there's going to be a converter here that automatically does it. So because you have to do it manually, but it's pretty easy to convert over. It's almost one-to-one, just like instead of using single quotes, using double quotes, using parentheses, and then you can just do more advanced stuff because of your skills from Kotlin transfer over, and you don't have to learn Groovy. Yeah, and then this is, so like this is an example project I've been creating, and then down here is like your dependencies. The sidebar is actually right here. So if I actually, I'm trying to think of something that's obviously I shouldn't do. What's something that would obviously give a warning? I don't know. What? What is it? Oh yeah. Seriously, like so, well, that's giving me an error, and you can see out to the right that the margin's yellow. I think there is like is there something else other than compile? Was compiled the one? Yeah. But like essentially the side margin will it'll give you yellow warnings if you're doing something that's not super bad. And that's basically what I would suggest. Like in my project, I have it set up as a rule that you can never have yellow warnings in the project, so I don't have it. So essentially the project won't compile if you have any warnings.
Do you guys have semicolons allowed?
Yeah, I think so. Let me actually throw some semicolons in here. I never do semicolons, so let's see here. Yeah. So okay, here's an example of the yellow, right? So this is teaching you to do Kotlin. So right here, I did a semicolon. It's grayed out, saying, "Hey, don't do it," and then it's a yellow mark. So like it kind of teaches you.
It also change your color settings. That's what I do. I have it highlights in yellow.
Yeah. Like there's lots of things that you can do if you. I like default settings. I like my stuff to look exactly like everybody else's. That's just the way I roll. So Gradle dependencies. So I just showed you the Gradle file, and essentially there's concepts that you should use to share your like versioning. So like let's say you have 5 dependencies that have the same version. Let's say like Hilt, which is the dependency injection framework in Android, maybe has 5 dependencies that all share the same version number. So there's best practices for sharing that version number. So like some of the ways, the old ways to do it is just kind of directly inside of your Gradle file, just put the version. Another way is to have a dependency Gradle file. So you just have a file called, like, let's say dependency.kt, and you include it at the top of your Gradle file. A more modern way to do it, and I would say the most popular way to do it, is a build source. So what it is you add this folder called build src, and there's a specific pattern that you follow, and you put your dependencies inside of that file, and that file will automatically get imported in all your Gradle files. That's the most popular way of doing it. That's kind of crufty just because it's you have to have nested, you have to have a folder and then a whole bunch of nesting inside of it in order to do a build source properly and have it automatically imported. And it feels like overkill. So there's actually a new way to do it, released in Android Gradle plugin 7.0, which just got released like really recently. I don't know if I put it on here, but so it's called Gradle version catalog, and actually I'm using it in my app. So what you do is actually define this TOML file. Okay, apparently my search sucks, but I might have to go to this. It's inside the Gradle folder. There's a TOML file, and in here there's like some sort of TOML format that you follow, and essentially you define your versions at the top here, and then you define. This is open source. I'll give you the link to this, guys, afterwards. Then you kind of define all your versions in here, and then inside your actual Gradle file, you actually just kind of follow this syntax to automatically import from that. This is the way that everything's going to go. It's almost certainly it's built in the Gradle. In order to use this, you need to, in your settings at Gradle, define that it's you can't read it, but it's, let me put an enter here. I could hide this somehow. Yeah, so like I define the that thing at the top that says version catalogs, and then it allows you to do it. But this is going to be the future of the way to do it in Android. Yeah, sure.
Is TOML also going to be the way to do it?
Yeah, it's the only way to do it with the version catalog. I don't know why they chose TOML, but they did. It's like it's some sort of the acronym for it is something sort of like very concise markup language or something like that. But I mean, it's fine. What? Yeah, maybe that's what it is. I mean, is YAML XML? Oh. Yeah, I don't know why they made that choice. Maybe this is their Gradle user guide for when it came out, so that might be an interesting read. Other properties?
Property files.
We don't really use those in Android, so I don't know. So like there is a Gradle.properties. Oh, I guess that's a good point. You might, I don't know if you could, I don't know if you can use that in that file. I don't know. You don't really define version here in your properties file, do you?
Oh. Yeah, sometimes.
Yeah. Yeah, I've never done that before. Yep. So yeah, essentially all your versioning is just defined in there. Any other questions before I go to the next?
Yeah, David, does that play nicely with auto-recommended updates? So for the longest time, inserting a variable on build, it wouldn't show libraries that had a newer version. They've got that working. Is that functional with
I don't know, and but there is this library that I have towards the end, which is called, I don't remember what it's called, but it's some sort of version plugin that you put into your application. And what it'll do is it'll automatically give you a report based off of that TOML file of what's out of date. And I think it'll automatically try to migrate you and update you. I'm not entirely sure. I haven't used it. I would imagine somebody's going to get it to work if it's not Gradle or Google or whatever needs to happen to make that happen. But TOML's definitely, this TOML file is definitely the future of, but it literally just came out, as far as I know. Anything else? Let me see here. I'm like, I could go freaking all night. I don't know what time dude, does anyone know what time I started? I just don't want to stand up here for like an hour and a half. But okay, so I think I will go till 7:15. So we'll go to the next slide. So the next thing I wanted to talk about is splash screens. Almost everybody does these wrong that I've ever seen. Like essentially, there's two different ways that I say that you should never do. Well, actually, there's only one way that I say you should do. But there's a separate activity with a timer, so it's like an artificial blocker to users to get to your first screen. So like you show a timer to animate or just artificially wait till the data is loaded without actually waiting for the data load. You just say like 3 seconds before my first screen gets loaded. That's bad practice because you're just kind of blocking the user from getting to the screen. There's also this premise of having a separate activity. So you have a splash activity that shows when your application loads, and then you immediately load the next page. So you don't have a timer, which is a little bit better. But the thing is, you're loading two activities, which is an activity is a screen, by the way, if anybody's not familiar with it on Android. So you're artificially loading two screens, which is an activity in itself is just a lot of memory that is unnecessary to load. So the recommended way is to do this activity with a theme swap. There's an article there, but essentially what it's doing is you're on launch, you're defining a theme in your app manifest, which is like your application file that gets read by the OS. And then that theme has a splash as the background. And then once your application, your activity is created, it'll call on create. And then inside of there, you swap it with your normal, your actual theme that doesn't have this splash screen as a background. So that's the recommended way that I've seen is the most efficient. Also, there's it's also recommended to just not have a splash screen in general. You're supposed to preview the content that they're going to see before they get there. So like if you have bottom tabs, bottom nav, you would show the bottom nav before the page loads. That's also another way to approach this. But with Android 12, which has not come out yet, they released a splash screen API. I haven't messed with it at all, but I imagine that's going to be the future way to do that. So it should be interesting. Any other questions?
What would you recommend if, say, you have bottom tabs, but maybe some of those tabs are traditional,
No, I still don't think that would necessarily, I think what Google or Apple would recommend in that situation is show bottom tabs, but without the tabs being there. So just have the bar. Yeah. So I think that's what I've seen the Apple-y way to do it. And I would imagine the same pattern would apply to Android. So that's what I would recommend if you're going for that pattern. A lot of apps do throw a splash screen on there. It's pretty normal.
I'm not sure, Android with splash, what you mean by splash screen, but and you're talking about switching between tabs with the application. When I think of splash screen, I hit the app and it loads the app and splash.
Yes,
that's
it.
That's it.
Yes.
What about you were talking loading it before you're going to need it, right?
Are you talking about one of these bottom two examples, the history separate activity, or are you talking about the theme, or are you talking about there's another way where you basically preview content? So it's essentially the preview content way, which is actually pretty crafty. I think it never actually works. I never actually seen an app actually do it, because the reason why is because you only can, from my experience, that is generally an image. You can't do an image that matches your bottom bar correctly usually. So it's usually not the best experience anyways. But I don't think I answered your question at all.
But are all tabs on the bottom bar?
What?
You're talking about tabs on the bottom bar?
Yeah.
So are you talking about switching between tabs having a splash screen?
No, I'm talking about just when your app launches, showing a preview. Let's say you have an app with 3 bottom tabs, it's always going to show in your application. The best practice is to show 3 bottom tabs at the bottom that are the 3 bottom tabs that you have, but they're unclickable until the page loads where it's actually able to be clickable. So I think generally how they do it is with an image or something like that. It just seems pretty crafty. I've never actually got it to work well. Almost everybody does splash screens, I think, or nothing at all. So design in general, you do whatever Google gives you. So the previous, I just put material down there just because there was material built into the platform. And the new recommended way is to use material components. And I just put in dark mode because you should be using allowing dark mode in your app if you can optimally. And then the future is going to be Android U, Material U. So what they're going to do is they're just going to make Material components work for Material U. So essentially what Material U is, to give you the crux of it, is it's instead of your app having its own theme, it's the person's phone has a theme and loads it into your app. So like, let's say they really like the color green for some reason. I don't know how exactly they picked this palette. Your app would be green.
That has to do with the latest standard release, where it's like everything's themed around whatever palette they chose.
Yeah, I don't know exactly how the palette gets chosen. I think it's related to their background screen or something like that.
User, yeah, they might have like a background and then they pick like a palette or font.
Yeah, maybe. Yeah, so like, yeah, that's not released yet, but that's but like that'll be given to you for free if you use Material components correctly.
Even like fonts, it also include fonts, or is it just fonts?
I don't think it's, well, does anybody know if it's fonts?
Because that would be a nice.
I don't know if it's.
I don't think it's fonts. Yeah, yeah, it would probably mainly be colors. Yeah, but it's not released yet, so I haven't really looked into it too much. But it seemed mainly to be a color palette, and it's opt-in. Like if you don't change your in your themes file, there's a file where you define your theme for your application. If you don't define in there that you want it to be Material U, you probably won't do it. And probably, to be honest, most apps won't do Material U. But it is there for you when you get there. So UI. So the traditional way to do it is with XML layouts and all that kind of stuff, which is at the bottom. That's the most popular way. Literally last month, they released 1.0 of Compose, which is the Android version of XUI Kit. What's it called? XUI Kit? What's it called? No, it's not called that. SwiftUI. Sorry, SwiftUI. So it's like the Android version of that. So I feel like if you're starting a new app now and you're not choosing Compose, you're probably doing it wrong. But it's probably going to be a struggle to learn it. Everybody's kind of learning together. I'm sure XML layouts for anybody is hard to learn for the first time, but I feel completely lost when I'm doing Compose. It's pretty new. It's pretty interesting, so I'm forcing myself to learn it. There's another library underneath it. It's called Accompanious by Google, which kind of is helpers on top of Compose. So also to give you an idea of what Compose is essentially it's UI in Kotlin instead of communicating between Kotlin and XML. So that's just the new way to do it. It's pretty awesome. Almost every single UI framework is going to a pattern like this of intermixing your code with your UI. So rather than having separate files, iOS used to do that, and Android used to do that as well. So
is that declarative in nature as well?
yeah, it's basically exactly the same thing. Yep, it looked exactly the same. Like, yeah, you defined. I can show you a quick example of what it looks like in the app. No, not data. UI, task list. So this is a screen. You define a screen as a function, actually, which is a little bit weird. But and then essentially you just kind of define. This is a top bar at the top here. Here's the content. Here's what you would think of as a recycler view, a column, two text, and a spacer. So it's just a recycler view here. And yeah, this is I'm still learning, so there's probably a lot of bad code with this Compose, but this works and kind of works exactly the same as SwiftUI. Any other questions?
See function builders, that's fun.
Yeah.
Now, how far does code go back to? What Android SDK version?
It's really old. It's like 21. We don't do.
That's the selling point.
Yeah, like it's probably way before 21. Like, but nobody supports anything before 21 anyway. So 21's Android 5.0, and we're on Android 11. So super old.
But is there anything like
I don't know if there is with Compose, and maybe somebody else can correct me, but there is a previewer inside of it. So essentially, as you're developing, there's a, I guess there, but you have to do everything in code. I don't think there's any drag and drop GUI yet. And I don't think there is in Swift UI either, right? You have to do it.
They have a canvas, it's kind of remedial, you can add and edit and that stuff. But
It's getting better.
it is. Just trying to keep my designers out of it. Next question.
Yes,
David.
absolutely.
So you say XML, and I understand
Yeah.
that, but I don't understand how to do it. Is that very, very similar to how Compose works? Like with UIKit and Swift UI, pretty much for Swift UI, we kind of turn everything over to Apple and let them change it. So like a software update could change how your app looks. Is Compose kind of the same as the XML where you control everything? And
Well, I think how it works is everything's tied into, well, actually, what you do is you define a bunch of dependencies, and the dependencies in your build.gradle tie you into a UI. So like you should not, when, as far as, I guess it's a mix, because the views are built upon the platform widgets. So it could change when you like upgrade your OS or something like that, but it shouldn't, because really everything on Android tries to go for like support libraries. So libraries you import in your app. So you're really importing the libraries in the app. The UI is controlled by these libraries. So like if you look at my build.gradle, I have all these dependencies for Compose. So like this kind of determines, oh shoot, I'm got this covering it. But like, yeah, this material got icons, view model, foundations. So like, I think the intention is when your UI should not change based on OS changes. I think that's the intention. I don't think they're probably trying to make very many changes to the platform, which there is a platform element which could break your stuff, but I imagine they test it to make sure it doesn't break your stuff. So it shouldn't break anything. Any other questions?
I have a question. How far back is Coroutine supported?
Like I don't know the answer to a lot of the backward compatibility things, because like in general, Android supports way before you like would ever think of. Like, so like anything's 21 plus, and if you're supporting 21, you're like being super modest. Like that's probably like 98% of Android users, some like 95% of Android users. They probably support, I would imagine, till like 15, something crazy like that nobody actually uses, or 16. But I don't really know. Like in general, nobody uses anything before 21 for years. Like my job's currently 21, but I'm pushing them to 23. So like almost everything's 21 now.
I'm just really salty about Swift's concurrency model being iOS 15 only. So
Yeah, I mean, like that's just their development model. I really like Android's model of support libraries to old versions. And the great thing about also the big benefit of them doing it like that is it's not tied into the platform. So like you have libraries that they can constantly churn on, and they're actually a lot of them are on like GitHub, and you can review their code and suggest changes and stuff like that. So Android's model is pretty nice for dealing with that kind of stuff. Any other questions? Everybody likes Compose. Everybody's excited about Compose. Everybody in Android is very excited about Compose too. So like you'll see a lot more apps, a lot more libraries come out. It's pretty exciting time in Android. Big changes too. So images. So the previous way to do images in Android was PNGs and JPEGs. Nobody does them anymore. Well, you shouldn't, at least. A lot of apps, a lot of people that don't like, the thing is like Android's really hard to keep on the top of. So like a lot of people still do it old ways. So like the intention here is to teach people the correct ways to do it. So like essentially the correct way to do it is vectors, which in the iOS ways is like PNGs. I think you actually support SVGs now because you guys are cool now. But so
terrible way. But
So yeah, vectors is like essentially like the most optimal image, and essentially it's like draw path, a very succinct, small code. But it's only possible for like non-photos, so it's more like for graphics and stuff like that. So if you need to do photos or something like that, essentially they recommend WebP, which is like just a Google format that is like you translate your PNGs or JPEGs into WebP, which is this second article here. Pretty cool. You should use it.
Yes.
GIFs are not, I think actually they're supported in Android, but only newer versions, but GIFs are an incredibly inefficient file format. Like in general, like, so if you want to use GIFs, generally what you would use is an image library, like I'm going to get into with Coil or Picasso or Glide. And essentially what you do is you import their GIF support, and then you could do an animated GIF. But animated GIFs are like super bloated files, so most people don't do GIFs in Android anymore. There's different things you could do. There's like more optimal paths, or like things like Lottie, which is like essentially it plays vector drawables. So like the most optimal format in Android or anything is SVGs, from my understanding. So essentially, if you can use SVGs to animate, that's the most optimal way, which that's what Lottie does. And I think there's probably other Android ways to do this that I'm not familiar with. I don't know if anybody else has any other things that you can do. But like essentially Lottie is what a lot of people use.
How am I going to create memes if I don't have GIFs?
You can use GIFs. Like it's fine. Like it's just if you're loading it from the internet, it's not so bad. You just don't want to bloat your APK with a whole bunch of GIFs. So if you're downloading from the internet and using your user's bandwidth, who cares, right? Okay, so image loading. This is actually a very big gray area. Like, I don't know what people recommend anymore. So there's 3 different top dogs here: Glide, Picasso, and Coil. They're all very good libraries. People don't really talk crap on any of them. Picasso died for a long time, for like a year or 2, but then it came back. So I think it's fine now again. Like as in it wasn't updating for a couple years, or a year at least. So I actually upgraded one of my apps a long time ago to Glide because I was like, oh, they're not updating anymore, but now they are again. So they're all fine. I would say probably if I was to give it a very opinionated choice, I would choose Coil. It's used in Accompanist, which is a compose library that you can use by Google. So it's built with coroutines, which I will talk about in a second. And it's just supposedly supposed to be mobile, but who knows? I say pick any of the 3. They're all fine. Any questions on that? They all support like GIFs. I don't know if they all support GIFs, but I imagine they all do. But I know Coil does, and I know Glide does. Yeah, all good libraries. So the next one is a little bit, this is pretty modern. I actually haven't used this until my most recent job, but navigation. So in Android, different ways to navigate between screens. The oldest way is to do an activity per screen, which is like a screen for an activity. The way after that was do a single activity and multiple fragments. So like one activity and then fragments are just kind of sub parts of the screen, but it can be essentially people turned it into a full screen because loading an activity is kind of heavy. So they tried to optimize for that. And then you use fragment transactions. I would say actually probably a lot of apps use that way over anything else. But the new recommended way, new-ish recommended way for maybe a year is to use single activity with multiple fragments with navigation components without compose. So that's what my opinion is. That's the most popular way to do it. Very long way to say it. So essentially, you have a single activity, multiple fragments. You use navigation components to navigate to different fragments. In general, I find navigation components to be very frustrating, but hopefully they keep making it better. And then the newest way, I haven't heard that they gave an official recommendation. Is that in this doc, they specifically tell you how to do it. But and also in my code example that I have, you can do a single activity, no fragments, and so basically multiple views with navigation components and compose. So that's pretty cool, because the thing that annoys developers in general with Android is dealing with activities and fragments, because they have these life cycles of destroying themselves, which are big pains in the butt. So if and then an activity life cycle with a fragment life cycle is even more confusing. So having only an activity life cycle to deal with is beneficial. So I think this will be eventually the future of Android, is going single activity, multiple views, and then hopefully eventually they find a way to maybe get rid of the activity, because the activity, when you actually look through the code, it's really crafty and it feels kind of like they shoved it in because they need to work with compose. But hopefully they find a way to optimize for that and maybe make the views last past configuration changes and do some cool stuff. I guess your view models last past configuration changes, which configuration changes are when your screens, there's lots of ways you can do it, but like if you rotate your screen, Android completely destroys your screen and recreates it. So you have to make sure you save your stuff in something, which usually you save it in a view model, which I'll get into, to persist that data. Any questions on this? This is kind of very interesting, and essentially all my Soros of Android are dealing with this library, but this is the recommendation. I'll go to the next slide. So sending data between pages. I see a lot of developers do this wrong, a lot of different ways to do it, but essentially the only way to properly do it is a bundle with parsable in the history, in my opinion. So essentially you define a class and you say it's parsable. It's a way to just, actually probably should add serializable. Serializable is a terrible way to do it in Android. It's always been discouraged. But a bundle with parsable, essentially you just define your model, your object, let's say a task object, and you define it as parsable, and you kind of do things in a certain way, and then you can pass it through with a bundle to, let's say you have a fragment A to fragment B. You could pass from fragment A bundle, which is like your task object, to fragment B, but you could only do it if you define it as a parsable. It's just a nuance of Android, just because of how Android works. But without compose, you can actually pass it with navargs, which are like automated generated classes. You still need to define your class as parsable, but you pass it through with navargs, which is essentially an automatically generated class that like you just pass it the class, and then and then you can define in fragment B a way to automatically get that class's value, and that's all through automatic code generation. Because with bundle with parsable, you have to grab everything by like a name. So if you want to pass something from task A to task B, you'd have to say, hey, this is the variable name you pass in a string. Let's say you do a string concept. You define that string concept as task, and then on screen B, you say, I want to pull the bundle, the arguments is task on screen B, and then say, hey, this is a task parsable, and then parse it out. It's kind of a pain in the butt, but the navargs automatically handles it for you. And if you're with compose, there's an example of how to do it with navargs there. Anybody have any questions about this? Probably really confusing, but it wipes away the activity. So there's concepts in Android, which is your screen. There is a concept of an Android that to persist that data past the life cycle of the screen. So like that's the big bane of Android developers' existence, is dealing with the life cycle. It's annoying, but the view model is the big savior there. Essentially what they do is they just save it in memory in the application, and then once you restore your application on the rotation, it identifies that you recreated the activity. It just restores the view model. It's pretty easy, but it kind of just works automatically. You don't have to think about it. Architecture. So in Android, it's been officially recommended for a while to use MVVM with repository pattern. The main reason is because the like I said, the view model lists past configuration changes, which is important. So there's a guide there, and also to follow the repository pattern, which is just a layer on top of your view model to abstract out your data. There's an article on there on how that works. Previously, before MVVM, it was pretty popular to do MVP, but since there's that ability for the view model to persist past the activity or the lifecycle of the screen, really most people are migrating to over MVVM, and they can use MVVM and then just kind of use their VP, kind of do their own, presenter layer on top of the view model, or you can use MVI with the view model. Here's an example here. It's interesting. I don't know if I fully buy on it. I don't like a whole lot of abstractions, but it's an interesting article that I think is pretty interesting, and it shows an example of how to do it with Compose, because Compose is pretty complicated with emitting events and stuff like that. So I haven't fully figured out my opinion yet there, but that's an article on that.
I'm familiar with MVC.
Yeah, like MVC doesn't really work in Android or iOS, because you're so like the MVC, so your view controller is too tied into your view, and there's no breakup in Android. Essentially, everything's kind of crunked together. Maybe with Compose, I'm trying to think of it would even make sense, but essentially nobody does MVC in when Android was really originally created. People tried to do MVC, but it just doesn't work in Android or iOS. So like you have to do MVVM, because essentially you want to break up your view from your logic, and yeah, I haven't thought about it since Compose came out, an exact reason why about nobody uses MVC. Yeah, but nobody uses MVC in Android anymore. Like, okay, so
It's not.
I'm trying to remember.
Sorry, I take line of a different.
No, that's all good.
You're on the side.
No, it's all good. Yeah, we can chat about it afterwards. I'm trying to remember what MVC, the difference was. I know what MVP is. I know what MVVM is. I haven't done MVC in so long. I don't even know actually what the definition of MVC is anymore.
The controller is like the coordinator. The controller creates the model. The controller can control the view. The model and the view aren't allowed to know about each other at all. It's like there's some sort of weird, like there's a little bit of two-way communication pattern between the controller and the model and the view, but like unawareness of the rest of it. Essentially, the controller, as the iOS funny thing is, it's massive view controller. It carries all the responsibility of data transformations, interpreting user inputs. Like it does the whole shebang.
Yeah, like I think like we were saying, I think the big problem is the view's so tied into everything that it's like impossible to decouple it. So like that's essentially what they follow the MVVM structure. So like essentially I think I actually have more slides on that, but like essentially your view model, you basically your view communicates to observes from your view model, and then there's ways to emit events to the view model. There's lots of different ways to implement it. Actually, I think my next slide. No, this is not the next slide. My next slide is coroutines. So this is how you do threading and reactive streaming in Android. So essentially, like the async await, this is the Android equivalent of an async await. So it's but it's a very, very clean and nice way to use it. The old ways to do is RxJava, which is there's an equivalent in almost every language, loaders and async tasks. But coroutines are very, very nice because you can essentially do works like in an observable fashion, or you could also do it in a one-time task fashion, and you can kind of abstract out the threading, and it looks you can define your code to not look like with callbacks and stuff like that. It just kind of looks, you can define your code to just look like method calls, but it's actually doing threading, which is pretty nice. Let's see here, ViewState. So the ViewState is essentially with MVVM, how you communicate between your view model and your view. So this ViewState, actually, let me go back to Coroutine. So like in Coroutines, you generally define suspend functions and flows. This best practice is really good. It kind of goes through that, but you define your suspend functions and your flows in your repository layer. That's how and then how your repository layer talks to your view model is through coroutines. State and shared flows are actually, I don't know. I guess they're not considered. I guess they are coroutines. So basically, what these are ways. It's how you should communicate from your view model to your view. So it creates an observable pattern. Generally, the pattern there, if you go to this article, is to kind of do what we were talking about with result. So like there's a single object that you're observing that has like a loading state, success or failure, and you can kind of observe on that. And the important thing there is that this is like there's ways to do this that's lifecycle aware, so it deals with the lifecycle, which is a big pain for Android in general. And the old way to do it is live data. Essentially does the same thing, but the benefit of shared flow and state flow is that it works well with coroutines. So it kind of makes it so you use coroutines all the way down. But yeah, live data is the old way to do it. It was built by Google, but it's almost everybody knows that everything's going to be going to state flow and shared flow. Dependency injection. This is kind of some people probably would disagree, but I would say in general, Google recommends Hilt, which is built on top of Dagger. So the old ways to do it is Dagger. Coin is another option. I personally think it has drawbacks. I wouldn't recommend it. We use it at my work right now. But Hilt and Hilt, which is built on top of Dagger, is the recommended way to do dependency injection. And there's a libraries of how to use it with Compose, with your view models and navigation, right there. Networking. So networking, we use basically everybody uses retrofit. Nobody uses Volley or HTTP URL connection. I don't know if anybody has any questions, but I'm gonna try to go through the rest of these real quick. Moshi is what I think is recommended as the JSON parsing framework. It's the quickest. It basically beats everybody out of like almost every metric. Protobufs are something built by Google. It's more optimal format than JSON, so it's something interesting to explore if you're trying to go for the most optimal format. A lot of apps don't use that. It's pretty rare. Then historical, most apps, if you look into their code, they probably use JSON. It's more of that's what they see in code examples than reason of choosing anything else. Nobody chooses on purpose, I would say. Kotlin Xcode, what's up?
JSON is very dangerous with Kotlin. It does not play nicely with non-nullables, so I would highly recommend avoiding JSON at this point.
Interesting. I think we use JSON at work. I don't know if we have. Oh no, we use Moshi at work. I'm sorry, I lied. Does it? Yeah, Kotlin X serialization. I don't know. Like last I heard, it's not anywhere near as good as Moshi, like speed performance wise. But I think it's going to be interesting, and I think Kotlin X serialization will work well with Kotlin Multiplatform, which is exciting. Which I have a slide at the end, but oh yeah, so simple key value store. So if you're not using a database, it's actually recommended to use Datastore instead of shared preferences. So that's something to keep in mind, because a lot of developers, when they think of solving this problem, the first thing they think of is go to shared preferences. It's just a way to save like a Boolean preference or whatever. Datastore is the new way to do it. If anybody has any question, database, everybody. Google created Room. There's also other options, Realm, SQLite, Delete. I recommend Room just because it's built by Google. It's going to be supported forever, and it seems to be built well. Oh, this is an interesting library that so like the repository layer, if you are trying to do some interesting database to networking to memory caching, Store is a very, very interesting library. So like traditionally, people write their own code for this. So essentially what it does, it'll like, like how people build caching layers that hit memory first. If memory doesn't exist, then go to database, and if that doesn't exist, go to networking. This kind of library kind of helps you with that code. It's pretty nice. Work Manager, I'll skip over this. This is recommended, don't use the other ones. App Startup is pretty interesting. I haven't seen a lot of libraries a lot of applications use that. What it does is it makes your application file in Android is more broken up. So rather than you having a whole bunch of stuff in your onCreate in your application startup, you can use this pattern to break up your application initialization, which is nice. I will skip all these so you can just kind of go through this. Nothing really important on there. Some things I recommend to keep your code clean is Kotlin as warnings as errors. So that'll make it so if you ever have anything yellow, your app won't compile. Lint warning as errors. So like essentially anything that Google defines as something you shouldn't be doing, define that as an error. KT-lint, essentially, I think it automatically formats your application. I haven't actually used it. I'm not sure what detect exactly does, but like these essentially are all for improving your code. And then this version refresh is for updating your, kind of giving you a report, and I think it automatically updates your dependencies. That's a little dangerous. I'm sure I don't understand these enough, but these are all things that you should explore if you're trying to create a well-built application. And this, my last slide is Kotlin Multiplatform. So this is the future. Oh, I was going to add some more features here, but Kotlin Multiplatform is a way you can share code between iOS and Android. I would say the reason why a lot of people are kind of skeptical of this as of now is because of the memory model that's built in Kotlin native. So once that gets fixed, which is an example, if you go to this link right here, there's an example solution that they have that they're working on testing. So they're definitely making good progress on it. So essentially, it'll make it so you don't have to deal with the memory the limitations of the Kotlin native compiler that they were using, which is how they compile stuff down to iOS. In Kotlin Multiplatform is pretty bomb because you can do web, iOS, and Android. Also, I just found that they announced JetBrains. I think just announced that you can use Compose in web. It's still new, but that's pretty interesting. So you can potentially make an Android application, cross-compile it. I think it actually uses Kotlin Multiplatform though, and then cross-compile it. So instead of having, so how Kotlin Multiplatform works is you actually have to build your application in Kotlin, but then your UI stuff is built in Swift UI or Compose on Android or in iOS and React. I'm sorry, web and React. So now they're developing a way that you can do Compose directly in web, which is pretty nice because then you don't have to learn that and you can kind of probably share more code, which will be interesting. I'm trying to think if there's anything else that I think.
They also announced desktop for Kotlin Multiplatform. It's another alpha right now.
With Compose?
Not with Compose, just with KMM, or but the multi-platform. Yep, desktop is the new thing, but I think Compose they're working on. Google is working on separately.
Okay, I thought they already supported desktop on Kotlin Multiplatform. I think Kotlin Multiplatform has supported like everything already, like web, iOS, Android, desktop, Mac. I think it already supports all those. It might be Compose that they had a support for, or maybe it's 1.0. Maybe it went to 1.0. Yeah, that's what it was. I don't know, but yeah. So that's essentially my presentation. Feel free to ask me any questions. I just want to go through my links. The first link here is a whole bunch of Compose examples. The second link is essentially somebody else that did my example code, but did a lot more cool stuff. He essentially he built his backend in Kotlin. He built his front end in Android. He's using like GitHub Actions, lots of kind of cool stuff. Using Compose, lots of cool stuff. His like essentially almost everything I'm trying to do with my sample app, he's done in a kind of a closer way. So it's a pretty cool application. And the last one is just an architectural sample that Google creates, which you can kind of look at, which is pretty nice to get ideas from. Anybody have any questions for me?
Okay. Like, down to Apple iOS. Does Apple even allow?
Yeah.
I mean, that's
Yeah, from my understanding, how it works is it compiles down to like LLVM. Maybe you can know better than me, but essentially what it does, and then essentially the API for interacting with it is it's like somebody wrote a library in Objective-C, and you can't have access to the code, but you have access to like interfaces in Objective-C. That's my understanding of how it works, and from my experience. So essentially, you have what's it called in iOS when you drag and drop a package? Is it called a package? Framework, yeah, it's like a framework file. You import it into your application in iOS, and then you kind of interact with it. So like the most optimal form of that is essentially your whole MVVM model is, except for your V, of course, is built into this package, and then essentially you pull out of that an observable. So you observe that, and then you update the Swift UI. That's like the optimal path of Kotlin multi-platform. But like, I kind of was looking into like, oh, maybe I'll do an application and kind of learn Kotlin multi-platform. The problem is like, you not only got to learn like Kotlin multi-platform and then Android, but you're also going to have to learn iOS. And if you want to do web, you have to learn web as well, because you have to do React. Or the cool thing about it now is it Compose. So like, what were you saying?
If you learn React, you might as well do React Native.
I'm very against React Native. That's a terrible choice, in my opinion. But I can go through that. Go through the many reasons why I think React Native is trash. But any other questions before I wrap up? We can hang out too if anybody has any questions. I have not tried Ktor. I just that's the sad thing about Kotlin multi-platform. It doesn't have retrofit, so it just feels to me like it might not be as nice. But you like it? Like, it'll be interesting to see if more and more applications kind of just do Kotlin multi-platform just in Android, and then try to eventually sell that on iOS. I think Kotlin multi-platform is probably the future, but we'll see how long it takes to get there. I've been saying that for at least a year and a half, probably 2, probably 3. But it is the future. Who knows when the future will get here?
right. Once everywhere.
Kind of, but the thing is, the problem with all those frameworks is that if you try to build UI in those frameworks, that's when you get problematic. That's also probably why Compose for web kind of is a bad idea. But if I want to get something out quick and dirty, that'd be nice to share between all the frameworks. And then if I wanted to invest time, I could switch the UI from Compose and web to React or whatever I decide.